Hi, my name is Mike Claron. I'm an engineer on the Android development team. Android is an open software platform for mobile development. It is intended to be a complete stack that includes everything from the hardware and up through applications. In the next few minutes, I'm going to be introducing you to an overview of the architecture of the Android platform, and I'm also going to talk about some of the key principles that are underlying its design. If we're going to talk about architecture, we need to start with a diagram covered with a lot of little boxes, and this is ours. Our architecture, we're going to start at the bottom and work up. Our architecture is based on the Linux 2.6 kernel. We use the Linux kernel as our hardware abstraction layer. So if you are an OEM trying to bring up Android on a new device, the first thing you do is bring up Linux and get all your drivers in place. The reason we're using Linux is because it provides a proven driver model, and in a lot of cases, existing drivers. It also provides memory management, process management, a security model, networking, a lot of core operating system infrastructures that are robust and have been proven over time. The next level up is our native libraries. Everything that you see here in green is written in C and C++. It's at this level where a lot of the core power of the Android platform comes from. I'm just going to go through and describe what some of these components are. I'm going to start with the Surface Manager. The Surface Manager is responsible for composing different drawing surfaces onto the screen. So it's the Surface Manager that's responsible for taking different windows that are owned by different applications that are running in different processes and all drawing at different times and making sure the pixels end up on the screen when they're supposed to. Below that, we have two boxes, OpenGL ES and SGL, and these two make up the core of our graphics libraries. OpenGL ES is a 3D library. We have a software implementation that is hardware acceleratable if the device has a 3D chip on it. The SGL graphics are for 2D graphics, and that is what most of our application drawing is based on. One interesting thing about the Android graphics platform is that you can combine 3D and 2D graphics in the same application. Moving over, we have the media framework. The media framework was provided by Packet Video, one of the members of the Open Handset Alliance, and that contains all of the codecs that make up the core of the media experience. So in there you'll find MPEG-4, H.264, MP3, AAC, all the audio and video codecs you need to build a rich media experience. We use FreeType to render our fonts. We have an implementation of SQLite. We use that as the core of most of our data storage. We have WebKit, which is the open source browser engine. That's what we're using as the core of our browser. It's the same browser that's powering Safari from Apple. And we've worked with that engine to make it render well on small screens and on mobile devices. Next is the Android runtime, and the main component in the Android runtime is the Dalvik virtual machine. The Android runtime was designed specifically for Android to meet the needs of running in an embedded environment where you have limited battery, limited memory, limited CPU. The Dalvik virtual machine runs something called dex files.dex, and these are bytecodes that are the results of converting at build time .class and .jar files. So these files, when they are converted to .dex, become a much more efficient bytecode that can run very well on small processors. They use memory very efficiently. The data structures are designed to be shared across processes whenever possible, and it uses a highly CPU-optimized bytecode interpreter. The end result of that is that it's possible to have multiple instances of the Dalvik virtual machine running on the device at the same time, one in each of several processes. And we'll see why that's important a little bit later on. The next level up from that is the core libraries. This is in blue, meaning that it's written in the Java programming language. And the core library contains all of the collection classes, utilities, I/O, all the utilities and tools that you've come to expect to use. Moving up again, we now have the application framework. This is all written in the Java programming language, and the application framework is the toolkit that all applications use. These applications include the ones that come with the phone, like the Home application or the Phone application. It includes applications written by Google, and it includes applications that will be written by you. So all applications use the same framework and the same APIs. Again, I'm going to go through and talk about what some of the main components are in this layer in the application framework. The activity manager is what manages the life cycle of applications. It also maintains a common backstack so that applications that are running in different processes can have a smoothly integrated navigation experience. Next down from that is the package manager. The package manager is what keeps track of which applications are installed on your device. So if you download new applications over the air or otherwise install applications, it's the package manager that's responsible for keeping track of what you have and what the capabilities of each of your applications are. The window manager manages Windows. It's mostly a Java programming language abstraction on top of lower level services that are provided by the Surface Manager. The telephony manager contains the APIs that we use to build the phone application that's central to the phone experience. Content providers are a unique piece of the Android platform. That's a framework that allows applications to share their data with other applications. We use that in our Contacts application so that all of the information in Contacts, phone numbers, addresses, names, is available to any application that wants to make use of them. And other applications can use that facility as well to share data. The resource manager is what we use to store localized strings, bitmaps, layout file descriptions, all of the external parts of an application that aren't code. I'm just going to touch lightly on the remaining four boxes: View System, Location Manager, Notification Manager, and XMPP Service. The View System contains things like buttons and lists, all the building blocks of the UI. It also handles things like event dispatching, layout, drawing. Location Manager, Notification Manager, and XMPP Service are some APIs that I think will allow developers to create really innovative and exciting applications. And the final layer on top is applications. This is where all the applications get written. It includes the home application, the contacts application, the browser, your applications. And everything at this layer is, again, using the same application framework provided by the layers below. Now, if you're going to write an application, the first step is to decompose it into the components that are supported by the Android platform. Here are the four major ones. We have activity, intent receiver, service, and content provider. An activity is essentially just a piece of UI, typically corresponding to one screen. So if you think of something like the mail application, that would be decomposed into maybe three major activities: something that lists your mail, something that shows you an individual mail message, and a composed screen to put together an outgoing email. An intent receiver is something different. An intent receiver is a way for which your application to register some code that won't be running until it's triggered by some external event. And the set of external events that triggers your code is open and extensible. So you can write some code and through XML register it to be woken up and run when something happens, when the network connectivity is established, or at a certain time, or when the phone rings, or whatever trigger makes sense for your application.